This is the start of chapter 2, and we're going to look at plotting y is equal to sine theta. Now to get some points at the beginning, I'm going to go by every 45 degrees. So we're going to start at 0 and keep adding 45. So we have 0 degrees, 45, 90, 135, 180, 225, 270, 315, and 360. So we're going to find the y value that goes along with each of these angle values when we're finding the sine of it. The sine of 0 degrees is 0. And I'm going to plot that right here. So if theta is 0 degrees, the sine of theta is also 0. That gives us our first point. The sine of 45 degrees. From our special triangle, the sine of 45 is 1 over root 2. And 1 over root 2 works out to be somewhere around 0.7. So if we go over 45 degrees, so my first tick is going to be 45 degrees, we go up to about 0.7. The sine of 90 degrees is 1. So at 90 degrees, we go up to a point of 1. What's the sine of 135 degrees? Remember, we start along the positive side of the x-axis. So if we rotate this way 135 degrees, if we rotate this way 135 degrees, in here we have an angle of 45 degrees. From the cast rule, the sine is positive up here just as it is here. So it's going to be the same sine as the sine of 45, making it positive 0.7. So we come back down. So here at 135 degrees, we're back down to 0.7. How about 180 degrees? What's the sine of 180 degrees? Now to get to 180 degrees, starting here, we rotate around to here. And when you're here, the opposite side is 0. The y value is 0. So the sine of 180 degrees is just like the sine of 0 degrees. It is 0. Okay, what happens when we keep going? Look for the sine of 225 degrees. Down here is 270 degrees. To find 225, we rotate 180, and then another 45 degrees after that, bringing us down here. So if this is 45 degrees, in our special triangle, the sine would be 1 over root 2, which is again 0.7. But over here, your y value is negative. So that makes that negative 0.7. The sine of 270 degrees, if we rotate all the way around, so let me put that negative 0.7 in here. For 270 degrees, if we rotate all the way around, this is 180, and now this is 270, the y value down here is equal to the r value, except it's negative. So the sine of 270 degrees is going to be negative 1. So over here we're at 270, and the sine is negative 1. If we keep rotating to 315, so from here all the way around 315 degrees, that's just 45 degrees short of a full 360. Again, we're in the same special triangle, And the sine here is the same as the sine here. They're both negative 0.7. So we come back up at 315. And finally, what's the sine of 360? Right here, we're at an angle of 0. For a 360-degree rotation, we rotate all the way around, and we arrive at the same spot. So the sine of 360 degrees is also 0. Now, if I connect those dots with the smoothest curve I can, this is what you get when you plot the sine of theta as theta makes its way from 0 up to 360 degrees. If we were to continue rotating past 360 degrees, all of these values repeat. You can verify that for yourself by continuing the rotation and looking again at the special triangle. As that pattern repeats, as we extend past 360 degrees, it'll continue to rise and continue to fall. The maximum value that it's going to have is positive 1. The minimum value that it's going to have is negative 1. Because it repeats, we describe this as a periodic function. It is periodic. And we say that the period is 360 degrees. That's the horizontal length that we have to go over to find a pattern that repeats. And another key term here is the amplitude. The amplitude is the maximum distance from the rest position. The rest position here is our 0 line. And the maximum distance that this curve ever gets from that rest position is 1. So it's periodic. We have a period of 360 degrees, and we have an amplitude equal to 1. And that's what you get when you plot the sine of theta. Y is equal to sine theta.